Hello friends, in the previous tutorial we talked about the singly linked list. In this tutorial we will talk about the remaining two types of linked list, that are circular linked list and doubly linked lists. In the last node of a list, the link field often contains a null reference, a special value used to indicate the lack of further nodes. A less common convention is used to make it point to the first node of the list. In that case, the list is said to be circular or circularly linked. Here the structure of the node remains unchanged as it was in a singly linked list. This is a logical representation of a circular linked list. Now we will talk about the algorithms on circular linked lists. The first one, that is C-traverse with a parameter start. This algorithm traverses the list applying an operation process to each element of the list. Start is the address of the first node of the circular linked list. Step 1, initialize the pointer ptr. Step 2, repeat step 3 and step 4 while ptr not equal to start. Step 3, apply process to info of ptr. Step 4, ptr now points to the next node. Step 5, exit. Now the second one, insert lock. It has three parameters: start, LOC and item. This algorithm inserts item so that item follows the node with location LOC, or inserts item as the first node when location equal to null. Step 1, check for overflow. Step 2, remove the first node from the avail list. Step 3, copy new data into new node. Step 4, if location equal to null, then A, set ptr equal to start. B, repeat while link of ptr not equal to start, ptr equal to link of ptr. C, set link of new is equal to start, link of ptr equal to new, start equal to new. Else if link of location equal to start, then insert as last node, else insert after the node with location LOC. And step 5, exit. The third one, that is del, it has three parameters: start, LOC and LOCP. This algorithm deletes the node n with location LOC. LOCP is the location of the node which precedes n, or when n is the first node, LOCP equal to null. Step 1, if LOCP equal to null, then delete the first node. Else if link of location equal to start, then delete the last node. Else delete node n. Step 2, return the deleted node to the avail list. Step 3, exit. Doubly linked list. In a doubly linked list, each node contains, besides the next node link, a second link field pointing to the previous node in the sequence. The two links may be called forwards and backwards, or next and previous. As shown here in the diagram, there is a pictorial representation of a node and logical representation of a doubly linked list. There is a header and a trailer in the doubly linked list. Now we will see few algorithms on doubly linked list. The first one, insert TWL. It has four parameters: start, location A, location B and item. This algorithm inserts an item between the address of location A and location B. Step 1. Check for overflow. Step 2. Remove the node from avail list. Step 3. Copy new data into the node. Step 4. Insert node into the list. Step 5. Exit. Now the second one, that is delete TWL. It has two parameters, start and location. This algorithm deletes the node with address stored in LOC. This algorithm deletes a node with address LOC in a doubly linked list. Step 1. Delete the node. Set forward of backward of LOC equal to forward of LOC and set backward of forward of LOC equal to backward of LOC, and step 2. Exit. Now circular versus linear linked lists. Advantages: if we are at a node in a circular linked list, then we can go to any node. But in linear linked list, it is not possible to go to the previous node. Second advantage is it saves time when we have to go to the first node from the last node in a circular linked list. It can be done in a single step because there is no need to traverse the in-between nodes. But in doubly linked list, we will have to go through the in-between nodes. Now the disadvantages. 1. It is not easy to reverse the linked list when it is a circular linked list. 2. In a circular linked list, we need to check that the problem of infinite loop should not occur. Third, if we are at a node and go back to previous node, then we cannot do it in single step. Instead, we have to complete the entire circle by going through the in-between nodes, and then we will reach the required node. Thank you.